Hello, my name is Nana Marroquin. I'm an avid math tutor, and today we are going to be talking about forces. So, we have this one problem, and let me pull it up for y'all. So, we're looking at problem 2-125, and the question asked us, determine the projected component of a force FAC along the axis of strut AO, express the result as a Cartesian vector. Okay, so what we're going to do is, step one is always to write down the information you know. So, we know, when we look back at the diagram, it tells us force AB and force AC are both 70 pounds and 60 pounds. So, we know FAB equals 70 pounds and force AC equals 60 pounds. And when we look back at the diagram, we're able to tell the locations of point A, point O, B, and C. So when we look at point A, we notice that it doesn't have an X coordinate, but has a Y coordinate and a Z coordinate. Point O is at the origin, so it's 0, 0, 0. B is at the negative x-axis, no y-axis, and a z-axis. And then point C, when we look back at point C though, we notice that it's at an angle. So we have to take that angle into consideration whenever we're trying to figure out its designated location. So we're going to say 5 cosine of 60, because we want the horizontal distance. We want the horizontal distance. It doesn't have a y component because this guy is along the wall. It's not protruding out of it like how the flower pot is. And we have a z component. So it's going to be 5 sine of 60. And this is going to give us the vertical component. Step 2 is to reread the question again, so we have a better understanding what it's asking us for. So here it says determine the projected component of force FAC along the axis strut of OA. So by just reading that sentence, we already know we're not going to need force AB, and we're not going to need point B for any of the calculations that we're about to do. What we need to do though is that step 1, we need to find the unit vectors for AC and the unit vector for AO. Then after that, we need to get the new force acting on the unit vector. So we're going to say FAC times the unit vector AC. Then lastly, we're going to do the dot product with that new force that we just calculated in step 2 with the unit vector of AO. Now, step 3, we're going to actually put these formulas into use. So, we're going to start off with point AC. So, AC is going to equal, we're going to get, and remember, whenever we're trying to find the new location of these points, we always read from left to right. So, I'm going to say 5 cosine of 60 minus 0, and this is all in the I direction, plus 0 minus 6 in the J direction, plus 5 sine of 60 minus 2 in the k direction. Okay? And now we're going to simplify this. This is going to be 2.5 in the I direction minus 6 in the j direction plus 4.33013. Sorry guys, that should be a 2. In the k direction. So now that we have this guy, whenever we're doing a unit vector, we have to remember unit vector has to equal the Cartesian vector divided by the magnitude of the Cartesian vector. Okay? So now that's what we're going to do. So I'm going to say 2.5i minus 6j plus 2.33013k divided by the magnitude, which whenever we talked about magnitude, that means we're going to get the square root of the vector. Vector components squared. So I want to say 2.5 squared plus 6, negative 6 squared plus 2.33013 squared. And this is going to give me my unit vector AC. So this should give you 0.3621 in the I direction minus 0.8689 in the j direction plus 0.3375 in the k direction. So now that we have the unit vector AC, we need to find the unit vector, and I'm going to do this one in green, of AO. So this one's going to follow the exact same steps. We're going to say 0 minus 0 in the I plus 0 minus 6 in the j plus 0 minus 2 in the k. So these are easier numbers to work with. So we get 0i minus 6j minus 2k. Now from here, when we're trying to find the unit vector AO, we're going to get our Cartesian vector divided by the magnitude of all of our components squared. And you don't have to really worry about putting the negative 6 and negative 2. You can just say 6 and 2 because the square of both of those values are still going to be the same. So here, we can say that this now equals 0i minus 0.9487j minus 0.3162. Okay. So now, after we get these two guys, we're going to move on to step 4. So what we need to do, we need to multiply force AC with the unit vector AC. And to do that is not any any different than regular multiplication. You're just going to get your force AC, which we said was 60, times the unit vector that we just found in the previous step, which we said was 0.3621 in the I minus 0.8689 in the J plus 0.3375 K. So when we do this, we come up with the value of, and we just distribute this guy. So don't get freaked out if you don't understand how I got my numbers. It's just straight multiplication. So it's 21.726 in the I direction minus 52.134 in the J direction plus 20.25 in the K direction. And remember your units, guys? We're all in pounds. Now our the second to the last step is now to do the dot product. So we're going to say force AC, unit vector AC, dot unit vector AO. So now we're going to do the dot product. And remember, whenever we do the dot product, and this is just an example, whenever we do the dot product, it's always going to be we're multiplying our I components together, our J components together, and our Z components together, and then we add everyone at the end. So we're going to do the same thing with the unit vector that we just calculated from earlier and that new force that we calculated from the previous step. So I'm going to say 21.726 times 0 plus negative 52.134 times negative 0.9487 plus 20.25 times negative 0.3162. So this should all give me 0 plus 49.45952 plus a negative 6.4031. What's this? All gives me 43.056 pounds. We're on our last step. We need to make this into a Cartesian vector. So to do that, we're going to get this force that we just calculated and do the exact same thing that we did back in the beginning when we were finding the new force AC. We're just going to multiply it with its unit vector. So I'm going to say 43.056 times negative 0.9487J minus 0.3162. Okay. So here, once again, just straight distributing. And our answer is going to be negative 40.8477J minus 13.6 6, 3, 8, 9 in the K direction. And remember that these are all in pounds still. And that's it, guys. This is our answer. We were working with forces. Our force happened to be in a coordinate system. And once again, my name is Nina Marroquin. I am an avid math tutor. And today we learned how to work with forces.